Hi, welcome to the COMSI 137 lecture. Sunny here. For this module, we will discuss the OSI reference model. Let's start. As you can recall, a network is a combination of hardware and software that sends data from one location to another. Hardware consists of physical equipment that carries signals. Software consists of instruction sets that make possible the services that we expect from a network. There are different companies that produces the networking equipment. Unfortunately, that created a problem in interoperability. The International Standards Organization introduced the Open Systems Interconnection model in the late 1970s. An open system is a set of protocols that allows any two different systems to communicate regardless of their underlying architecture. The purpose of the OSI model is to show how to facilitate communication between different systems without requiring changes to the logic of the underlying hardware and software. The OSI model is not a protocol. It is a model for understanding and designing a network architecture that is flexible, robust, and interoperable. The OSI model was intended to be the basis for the creation of the protocols in the OSI stack. The OSI model is a layered framework for the design of network systems that allows communication between all types of computer systems. It consists of 7 separate but related layers, each of which defines a part of the process of moving information across the network. Layer 1 is the physical layer. Layer 2 is the data link layer. Layer 3 is the network layer. Layer 4 is the transport layer. Layer 5 is the session layer. Layer 6 is the presentation layer. Layer 7 is the application layer. The three upper layers are called the user support layers. They provide interoperability among unrelated software systems. They are implemented in the software. The lower three layers are the network support layers. They are involved in the physical aspects of moving data. They are implemented in hardware and software. The physical layer defines the connector and interface specification, as well as the medium requirements. Electrical, mechanical, functional, and procedural specifications are provided for sending a bit stream on a computer network. The physical layer also concerns on the physical characteristics of interfaces and medium, the representation of bits, data rate, synchronization of bits, line configuration, physical topology, and transmission mode. Some components at layer 1 are the cabling systems, the adapters, the connector design and pin assignments, hub, repeater, and patch panel, wireless system components, spiral SCSI, and the network interface card. The data link layer transforms the physical layer to a reliable link. It makes the physical layer appear error-free to the upper layer. Some of the functions of the data link layer are framing, data link addressing, flow control, error control, and access control. Some components are the switches and bridges. One of the main functions of data link layer is the hop-to-hop delivery. The network layer is responsible for the source-to-destination delivery of packets, possibly across multiple networks. There is no need for the network layer if two systems are connected to the same link. Its functions are logical addressing and routing. Again, its main responsibility is the source-to-destination delivery. The transport layer is responsible for the process-to-process delivery. It ensures that the whole message arrives intact and in order. Some of the functions of transport layer is the service point addressing, segmentation and reassembly, using sequence numbers: connection control, flow control, error control. The session layer acts as a network dialog controller. It establishes, maintains, and synchronizes interactions among communicating systems. It synchronizes by adding checkpoints. The presentation layer is concerned with the syntax and semantics of the information exchanged between two systems. Its main function is the translation, encryption, and compression of data. The application layer enables the user, human or software, to access the network. It provides user interfaces and support services like email, remote file access and transfer, shared database management, and distributed information services. Other services include network virtual terminal, file transfer, access and management, mail services, and directory services. In summary, the physical layer is responsible to transmit bits over a medium, to also provide mechanical and electrical specification. The data link layer is responsible to organize bits into frames, to also provide hop-to-hop delivery. The network layer is responsible to move packets from source to destination. It's also responsible to provide internetworking. The transport layer is responsible to provide reliable process-to-process message delivery and error recovery. The session layer is responsible to establish, manage, and terminate sessions. The presentation layer is responsible to translate, encrypt, and compress data. The application layer is responsible to allow access to network resources. When we compare the two models, we find that two layers, session and presentation, are missing from the TCP/IP protocol suite. These two layers were not added to the TCP/IP protocol suite after the publication of the OSI model. The application layer in the suite is usually considered to be the combination of three layers in the OSI model. Two reasons were mentioned for this decision. First, TCP/IP has more than one transport layer protocol. Some of the functionalities of the session layer are available in some of the transport layer protocols. Second, the application layer is not only one piece of software. Many applications can be developed at this layer. If some of the functionalities mentioned in the session and presentation layers are needed for a particular application, they can be included in the development of piece of that software. The OSI model appeared after the TCP/IP protocol suite. Most experts were at first excited and thought that the TCP/IP protocol would be fully replaced by the OSI model. This did not happen for several reasons, but we described only three which are agreed upon by all experts in the field. First, OSI was completed when TCP/IP was fully in place and a lot of time and money had been spent on the suite. Changing it would cost a lot. Second, some layers in the OSI model were never fully defined. For example, although the services provided by the presentation and session layers were listed in the document, actual protocols for these two layers were not fully defined, nor were they fully described, and the corresponding software was not fully developed. Third, when OSI was implemented by an organization in a different application, it did not show a high enough level of performance to entice the Internet Authority to switch from the TCP/IP protocol suite to the OSI model. Actually, there are other reasons why the OSI model failed. They are documented in Andrew L. Russell's The Internet That Wasn't. Please read the article. That's it for Module 4. Thank you.